Hello and welcome to this video where I'll be explaining how to use the elimination method to solve sets of linear simultaneous equations. There are two main methods to solving simultaneous equations. One is substitution and the other is elimination. I'll put a link to the substitution method down in the description below. The elimination method can be a simple method to quickly solve simultaneous equations if they're written already in a suitable form. If your pair of simultaneous equations is going to require lots of rearranging in order to use the elimination method, I would suggest you maybe use substitution instead. The elimination method can also only really be used for equations that are both linear. There will be another video where I talk about how to solve quadratic simultaneous equations. I will link that down in the description as well. So let's take a look at our first example here. We can see that the equations are neatly lined up where the x's are both on the left-hand side, the y's are both on the left-hand side, and on the right we have integers. If your equations come to you in this form, elimination is going to be the method for you. The goal of elimination is to remove one of the variables so we are left with the other. In this case, my goal will be to remove the y values from both of these equations and somehow end up with an equation with only x's. To do that, what I'm going to do is to either add or subtract the two equations together. Now, before we do this, I highly suggest you label your equations 1 and 2. This will become particularly important when we are doing harder examples. Here, I'm going to add the equations together. And the reason why is that I have identified that I have a negative y in the first equation, and I have a positive y in the second equation. Now, if I was to add negative y and positive y, that would equal 0, hence eliminating the y's from the equations. To keep track of what I'm doing, I'm just going to write down that I'm doing 1 plus 2. Okay, and that's why I labeled my equations before, because I want to be able to keep track of what I'm doing. So I'm going to copy my equations over, add a little line underneath, just as if I was doing addition. I'm going to line up the x's, so I've got 2x plus my x underneath, which will leave me with 3x. My negative y plus my y underneath, we already said would leave me with 0. And so my final job is to add the right-hand side, which will leave me with 153. Now I'm left with an equation with only one unknown variable. That is excellent because all I have to do now is divide both sides by 3 to be left with x equals 51. Remember, the goal of solving simultaneous equations is to find the pair of x and y values that will satisfy both the first and the second equation simultaneously. So that means I also need the corresponding y value to this x value of 51. To do that, I can take this x value and find an x in either the first or the second equation and simply replace that with the 51. So I'm going to choose the second equation, I'm going to replace x with 51, keeping everything else the same. I can now subtract 51 from both sides, and that will leave me with y equals 67. So this pair of numbers, 51 and 67, will satisfy both equation 1 and equation 2. This is something we can always double check. So if we take our x value and place it into equation 1, I would get 2 times 51. If I take my y value and place that back into equation 1, I would now get minus 67. So we can work this out. That would be 102 minus 67. Which, when we calculate, we find to be 35, just as expected in that equation there. Let's have a look at this example. We can see straight away that there are no x's or y's here that can be simply added or subtracted to each other to eliminate that variable. We don't have the same coefficient in front of the x's, and we don't have the same coefficient in front of the y. So that's going to be our first goal. We're going to manipulate the equations to change those coefficients. We're going to label our equations 1 and 2 again. I'm going to now try and eliminate the y, just like in our first example actually. So I'm going to take the second equation, and what I will do is multiply that whole equation by 3. So that will multiply the left-hand side and the right-hand side by 3. Be careful to multiply every term. That's going to give me 3x plus 3y equals 15. So this is 3 times x, this is 3 times y, and this is 3 times 5. I'm now going to label that equation number 3. So when it comes to doing the elimination step, I'm actually going to be comparing this first equation to this third equation, as now I have the same coefficient in front of the y's, the sign is merely different. As the signs are opposite, I can do exactly the same as the first example, where I add together the left-hand sides, and the minus 3y will cancel out with the plus 3y. Okay, now we've lined those equations up. Let's put our line underneath, make sure we know we are doing addition. And let's start with the x's, so 6x plus 3x is 9x. Negative 3y plus 3y is going to give me 0. And on the right-hand side, 3 plus 15 is 18, leaving me with x that is equal to 2. The next step is to take that x value and place it back into one of my initial equations. I'm going to choose equation number 2. So the x is now replaced with 2. We're going to copy over the rest of the equation the same. Now subtract 2 from both sides, leaving me with y equals 3. Remember to always double check your answer by placing it into one of the other equations. So 6 times my x value of 2 minus 3 times my y value of 3 is going to be 12 minus 9, which is absolutely equal to 3, corresponding to that first equation. So we know we've got our answer correct. This example is slightly harder than the previous two. Neither the x nor the y coefficients can be multiplied quickly to be the same in the first and the second equation. There's no quick fix to multiply this 2 to turn it into 5, or this 3 into 2, for example. So what we're going to do this time is multiply both equations by something. Let's first label them 1 and 2, and then let's think about what we would like to achieve with the coefficients of either x or y. Here I'm going to pick the coefficients of x. I would like to make them the same. What that effectively means is I'm looking for the lowest common multiple of these two coefficients, the 2 and the 5. Now hopefully you will know that the lowest common multiple of those is 10, and that means what I will need to do to achieve that is multiply equation 1 by 5 on both sides, and multiply equation 2 by 2 on both sides. So this will give me my equation number 3, and this will give me my equation number 4. Let's quickly do that then. So multiplying both sides of equation 1 by 5 leaves me with 10x plus 5 times 3, 15y. And remember to multiply the right-hand side by 5 as well, leaving me with 25. And multiplying both sides of the second equation by 2, we will get this. We can now see that the coefficient of x is in fact the same value. Now, the previous two examples, we had a positive and a negative number in front of our letter that we were choosing to eliminate. Here, we can see that the sign in front of both is the same. So instead of doing an addition, what I'm going to be doing is a subtraction of these two. Let's pop our line underneath then and see what happens. So 10x minus 10x is going to cancel out and leave me with 0. So eliminated the x's there. Now 15y minus negative 4. Be very careful when you're doing this with your negative signs. So that is actually 15y plus 4y. And over on the right-hand side, we have 25 minus 32. So that is effectively 25 plus 32, leaving me with 57. Now I can divide both sides by 19, giving me y equals 3. Final step is to take that value back up into the equations. So let's do 2x plus 3 times my found value of y, which is 3. 2x plus 9 equals 5. Quickly subtract the 9 from both sides, and now divide both sides by 2. That'll leave me with x equals negative 2. Remember to plug those x and y values back into the initial equations to double check your solutions. Let's have a look at one final example. We can see that much like the previous example, we're going to have to multiply both of these equations by something. So let's label them 1 and 2 to begin with. Now I think that y is going to be slightly simpler to eliminate. The lowest common multiple of the 3 and the 2 is going to be 6. So equation 1 needs to be multiplied by 2, and equation 2 needs to be multiplied by 3. Okay, and that will give me my equations 3 and 4. Let's do that then. So 14x minus 6y, and be careful with this fraction. So we're going to multiply 5 over 4 by 2, leaving me with 10 over 4. Or if we would like to simplify that, we can write that as 5 over 2. Let's multiply both sides of the second equation by 3, giving me 9x plus 6y equals 9. So the coefficient of the y's is the same apart from the sign. That means I'm going to be adding my two equations together in order to eliminate y. So 14x plus 9x is 23x. The y's, as we said, eliminates, and the 5 over 2 plus 9 is going to be 23 over 2. I can now divide both sides by 23, leaving me with x equals a half. So that answer is quite nice, even though we had a fraction in our simultaneous equation to begin with. Of course, we now need to go in and find our value of y. So let's use the second equation here. 3 times a half, which is my value of x, plus 2y equals 3. So we've got that 3 over 2 plus 2y equals 3. You can subtract the 3 over 2. So 2y equals 3 over 2. Finally, dividing both sides by 2, y equals 3 over 4. Remember to plug those back in to double check your answer. So that's our final example for today. This was the method of elimination for solving simultaneous equations. It only really works, remember, for linear equations. Don't use this method when we're dealing with quadratics or higher order simultaneous equations, but it's a very quick method when the equations are in the right form. I hope you enjoyed this video, and I hope to see you again in the next one.